Hello student, I would like to welcome again to my course. So, today we will discuss genetic algorithm. Already we have discussed the classical method. So, now you know how to solve a nonlinear optimization problem, mainly the convex your problem using classical method. Then we have also discussed what is the difficulties difficulty you have faced in solving some of the nonlinear problem, mainly which are non-convex problem, and if your problem has more than one optimal solution, that means you have multiple optimal solution, then really it is difficult to solve the problem using classical method. So, today also I will show you some of the difficulties, so that you may face in solving a non-convex problem having multiple optimal solution using classical method. So, initially we will discuss about the difficulties faced while applying classical method, and then we will discuss the genetic algorithm. So, I have shown here a function, and if you look at this particular function, there are several optimal solutions. So, what is optimal solution? The first derivative is 0. So, these are all stationary points. Okay. So, these are all stationary points, and so you can say that these are all optimal solutions, but one of them is the base solution and we call it global optima. So, we call it global optima. So, within the search space, so in this case the search space is coming from here to here. So, within this search space, this is the solution and this is the base solution, and I can say that this is the global optimal solution of this problem. Now, the other solutions, so the first derivative is 0 in other solutions also, and we call it local optimal solution. Now, let us see if I try to solve this problem using classical method. Okay. So, just see, this is not an easy problem to be solved using classical method, but you just try to solve this this problem using classical method. Now, as you know that the classical method, so whatever the gradient based method you are applying, so it is starting with a initial solution. So, we call it x naught. So, x naught is a initial solution, that means the search process is starting from this x naught. Now, how to choose this x naught? Suppose in this case, if you are selecting an x naught somewhere here, suppose if x naught is somewhere here, then you will get this optimal solution. If your x naught is somewhere here, you will get this optimal solution. If it is somewhere here within this particular range, you may get this optimal solution, and if your x naught is within this region, you may get this optimal solution. And luckily, if your x naught is in between this somewhere here, so in that case the global optimal solution of this particular problem. So, therefore, the solution is highly related to what initial solution you have chosen. Okay. So, if you have luckily chosen a correct initial solution, so in that case you may get the global optimal solution of this problem. Otherwise, what you will get? So, if you apply classical method, so you will get a local optimal solution. So, now what should be the procedure? What you should do basically if you apply classical method? So, what I will do, that I will search for optimal solution by changing the initial solution. So, initially you have chosen a random initial solution between upper bound and lower bound within the search space, and then you get an optimal solution. Now, you change the initial solution and just see whether you are getting a different solution or not. So, in this case you will be getting a different solution if your initial solution is different range. So, what will happen, that depending upon that what initial solution you have taken, so you will get one of these local optimal solution of this problem. So, therefore, if you are lucky and if you have chosen the correct initial solution, so in that case you will get the global optimal solution of this problem. So, therefore, this problem is not easy to solve, okay, using classical method. Now, let us see, I have shown 3 functions here. So, already I have discussed what is optimization problems. I think you already know that optimization is an act of obtaining the best result under given circumstances, and it is a mathematical discipline which is concerned with finding the minima or maxima of a function and possibly subjected to constraint. So, now let us see these 3 functions. Suppose the first function, if you see that this is an relatively it is an easy your function, if I say, or I can say this is a simple function and this is a convex problem. So, if you take initial point anywhere in the search space, so you will get the your optimal solution, and there is only one optimal solution here, and that is the global optimal solution of this particular problem, and this function is a convex function. Okay. So, it is a convex function, there is only one optimal solution, and that is the global optimal solution of this problem. So, what I suggest that for this particular function, so if you apply classical method, you will get the your optimal solution of this problem. So, therefore, this particular problem is easy to solve. So, I am not suggesting that you apply genetic algorithm or any other your types of meta heuristic algorithm for solving this problem. So, simply you apply classical method, because the function is a convex function, and you know that for convex function the local optimal optima is also global optima. There is only one optimal solution of this particular function. Okay. Now, let us look at the second function. So, second function is relatively difficult function. Okay. So, the second function is relatively difficult function. So, here you have 4 optimal solution, and if you are taking some initial solution somewhere here, you may get this optimal solution. If you are taking somewhere here, you may get this one. If you are taking somewhere here, you may get this one, or if you are taking somewhere here, you may get this solution. So, for this particular function, so depending upon what initial solution you have chosen, so you will get one of the local optimal solution. So, you will get one of the local optimal solution, and basically it is sensitive to the initial solution. But still I say that this problem can also be solved using classical method. You just change your initial solution, and you may get one of the optimal solution, and if you do some random trial, probably you may get all these 4 optimal solution of this problem. So, you may apply classical method in this particular problem. However, if you look at the third problem, that is not an easy problem. There are several local optimal solutions, and one of them is the global optimal solution of this function, and you just see. So, it is quite difficult to solve this problem using classical optimization technique. So, in that case, so you need some special treatment, or you need some specialized algorithm for solving such type of problem. Okay. So, if I look at all these 3 functions, as I said, the first function is easy to solve by classical method. So, you can apply classical method for solving this problem. So, you need not apply the non-classical technique for solving these types of problem, but if you go to the second problem is relatively difficult to solve by classical method, but still you can apply classical method and you will get the your local optimal solution, or with some iteration you may get the global optimal solution of this problem. But if you look at the third problem, that is difficult to solve using classical method. So, it is very difficult. Okay. So, you may do lot of iteration. Suppose you are doing lot of iteration by changing the initial solution, you may get the global optimal solution, but it is really difficult to solve using classical method. For such type of problem, so you need a different algorithms. Okay. So, for solving this problem, so need different algorithm to solve this type of problem. So, I will suggest that if your problem is something like that, then you can apply non-classical method to solve the problem. So, today we will discuss the genetic algorithm. So, you can apply genetic algorithm, or otherwise if it is easier, so easier to solve suppose first type and second type problem, you can apply the classical methods. Now, let us discuss genetic algorithm. So, what is genetic algorithm and how it is derived basically, what is the principle, what is the philosophy. So, we will discuss this one. So, principle of natural evolution. Okay. Now, if you look at the population, so you just look at the population. So, in nature basically, so we are not living as an individual, but we are living as a population. Okay. Now, this population is struggling for existence. Okay. So, struggling for existence, and we call it survival of the fittest. So, what will happen? This population is struggling and the fittest will survive. Okay. So, this is the natural law basically, the fittest will survive, and those who are not fit, they will be eliminated from this process. Okay. Now, those who have survived, these surviving individuals, okay, surviving individuals reproduce. Okay. So, they produce their offspring, then they also propagate the favorable characteristics to next generation, to their offspring. Okay. So, what is happening? This surviving individual, they reproduce, they propagate the favorable characteristics. So, whatever what favorable characteristics they have, I will also explain this thing in some of the slide. So, the favorable characteristics they propagate and to their offspring, and this is known as evolved species. So, whatever new species you have basically, we call it evolved, because they are slightly different to their your parents, okay, than their parents. So, they are slightly different their parents, and it is basically we call it the evolved species. Okay. And then this process is continuing in nature, and still this process is continuing. So, population, they are struggling for existence. So, we call it survival of the fittest, that means those who are fit, they will survive. Then surviving individual, they reproduce and propagate favorable characteristics to their next generation, okay, and this is known as evolved process. So, now what is the basic principle of natural selection? So, principle is select the best, discard the rest, select the best, discard the rest. That means the best solution, if I say from natural point of view, the best, the fittest solution, they will survive, and the other, those who are weak, okay, they will be eliminated. So, nature will discard them. So, there are several examples that those who were there maybe millions years back, so now they are not in existence. So, they are not there. Okay. So, how they have eliminated? Because they could not survive in that struggle for existence, okay, survival of the fittest. They could not survive, and they are right now, they are not there. So, that has been eliminated by nature. So, now the basic question is, whatever happening, that search process, I can say this is a search process. So, every time you are getting a new solution. Okay. So, how you are getting a new solution? Because they reproduce and they propagate the favorable characteristics, and due to that you are getting a new solution, and probably you are reaching some optimal solution, and they are basically in existence. So, now the question is that whether there is a random search or it is a guided search. So, whether whatever evolved process, so we are evolving. So, this evolved process is a random search process or it is a guided search process, whether it is guiding by some rules or somebody is guiding it. Okay. So, before that we have to understand what is random search and what is guided search. So, in the next slide I will explain what is random search and what is guided search. Now, just take an example of these building blocks. Okay. So, now you have, this is a very simple problem. So, I would with this I would like to explain what is random search and what is guided search. So, now I have 4 letters, and this is O, L, Z, A. So, these 4 letters I have. Now, I am asking you that you create the word goal using this letter. So, that is not that difficult. So, what you can arrange this letter, that GOAL, goal, you can basically arrange this letter in that order, and you can write the word goal. So, this is not a difficult problem. Now, if I put some difficulty in this particular problem, so what difficulty? That I will put a blindfold on your eyes. Okay. So, I will put a blindfold, and then what will happen? You will not be able to see. Now, I am asking you that you try to create the word goal using these 4 letters. Okay. And what I will do? I will reshuffle it. I will put in a put on a table, and then with that blindfold, you just try to make that word goal using these 4 letters. So, now only what help I can do basically, or what I can tell you, that once you are arranging the letter, then I can say that whether you got the solution or you are not getting the solution. So, if you got the solution, I will say yes, okay, this is the solution. You could arrange the letter in that sequence and you are getting the solution. So, I will say yes, or otherwise what I will do? I will say no. So, you are not getting the solution. So, this is the only information I will give you, that yes or no. Okay. Now, you try to do that. Okay. So, what will happen? So, your objective function is this. Objective function is that you try to create this particular word, that is the objective, and then first trial is AOLG. So, this is the first trial, you have arranged something like that. So, then what I will say? I will say that this is not the solution. So, I will say no. Now, what you will do basically? Then you will again rearrange those things, rearrange this for your letter, and you will give another trial, and suppose this is the second trial. So, second trial you are getting GLOA, that is also not the solution. So, then what I will say? I will say no basically. Now, you see how much iteration you may need or you may require to get the optimal solution of this problem. So, you are not sure basically. So, it may take your few hundred or some iteration you may need to get the solution, that means that GOAL. Now, this is purely random search. Okay. So, because suppose there is no interlinking between first trial and second trial, this is purely a random process. So, you are rearranging this your letter, and there is no interrelation between first trial and second trial, or second trial and third trial. So, this is a purely random process. I hope this is clear to you what is random process. Now, second is I am giving you some more information. Okay. So, apart from yes or no, I will also tell that whether you are partially correct or not basically. Suppose if I say that in the second trial the first letter is correct, that means you got the first letter. Okay. So, GOAL you should get, but you got the first letter, that means first letter is correct, that you got Z. So, this is the additional information I am giving to you. Okay. So, that means the first letter is correct. Then what will happen? Then what will happen? That you are basically you will fixing that one. Okay. First letter you will fix. Then you will try to rearrange the rest 3. Then suppose next time I am telling the fourth one is correct. Okay. Then you will fix the fourth one, and then basically I am saying the third one is correct. So, something like that. So, in that case what will happen? In that case, you just see the difference between first method and second method. In random search, there was no information about your partial your correctness of this particular your solution, but in the second you are getting some additional information. So, in the second method, so you will get your solution probably in a lesser iteration. So, this search is guided search, that means somebody is guiding this search. Okay. So, therefore, you are getting your solution in a lesser time. I hope this is clear to you. So, we have discussed mainly what is random search and what is guided search. Now, question is that, so what is the natural evolution process? So, whether it is a random search process or it is a guided search process. So, it is not a random search process, because there is a interlinking between the trial, between the events. Okay. So, therefore, this is not a random search, this is a guided search. Okay. So, how it is, who is guiding basically. So, that I would like to explain in the next slide. Let us see another example problem. Okay. So, another example. So, if you look at giraffe, okay. So, I think all of you have seen that one. So, if you look at now giraffe has longer neck, neck is longer, but millions of years back basically they have shorter neck. Okay. So, some studies saying that they had actually shorter neck actually. Now, what happened at that time, the giraffe, so giraffe with slightly longer neck could feed on leaves of the higher branches when all the lower leaves had been eaten off. Okay. So, when there was no leaf on the ground, so the giraffe with slightly longer neck, they are in an advantageous position and they could take the leaf from the higher branches. Okay. And that had a better chance of survival. So, therefore, what has happened, that those giraffe having slightly longer neck, so they had a better chance of survival, because when there are no leaves on the ground, they can take the leaves from the higher branches. Okay. So, they had a better chance of survival. Now, if you look at, this is a favorable characteristics, okay, of that particular giraffe. So, some giraffe they have longer neck, and this characteristics what is there in their gene basically. So, that is basically you can say that is a favorable characteristics. Now, what is happening? This favorable characteristics propagating to their offspring. So, favorable characteristics propagated through generation of giraffe. Okay. So, that has been propagated, and now they evolve to a new species and which has basically longer necks. Okay. So, they evolve, this species has longer neck. So, this is basically you can say, now what is happening. So, whatever giraffe, so shorter one, the giraffe with shorter neck, they could not survive because that was not a favorable your characteristics. But what is favorable characteristics here? The favorable characteristics is the longer one, giraffe with longer neck, and they could survive and other could not survive, and therefore, this evolved to a new species, and those now whatever we are getting basically these giraffes are having longer neck. Okay. How they are getting longer neck? This longer neck may have due to the effect of mutation initially. So, initially because of mutation some giraffe may had a longer neck, however, as it was a favorable and this was propagated over the generation and this is basically evolve. So, you are evolving in a new species. So, I would like to give you another example. Suppose we are living at an altitude of around 200 feet to 300 feet, and if you compare the temperature, pressure and oxygen level with an altitude of 1000 feet or 1500 feet, something like that. So, there is a huge difference, oxygen level will be lower at an higher altitude. Now, question is that, so if you are putting a suppose if you are shifting 100 people from this altitude to a higher level altitude. So, what may happen, that some may not be able to survive at that atmosphere, because less oxygen, temperature is different, pressure is different. So, some of that population may not be able to survive at that, but there will be some individual who will be able to survive at that oxygen level, because and that is a basically favorable characteristics for them. So, now what will happen in the next generation, these favorable characteristics will be propagated to their offspring, and then this is basically evolve as a new species. Now, this species basically they can survive with lesser oxygen. Okay. So, we call it adaptation. So, we can adapt to a new environment, okay, and that is basically propagated to through generation, and then basically after few generation. So, they will be able to survive with lesser oxygen, okay, at that higher altitude. Now, what Darwin's principle of natural selection. So, the principle said if there are organisms that reproduce, okay, so if there are organisms that reproduce, if offspring inherit character from their progenitor, okay, so they are whatever characteristics they have, they are getting or inherited from their parents. If there is variability of character, so whatever the character of each population or each individual of the population, and there is a variability of the character, and if the environment cannot support all the member of the growing population, then what will happen? Those members of the population with less adaptive trait will die out. So, what I am telling that when you are not adapting or to that change environment, then what will happen? They will die out. Okay. Then those members with more adaptive character will flourish. Okay. So, what will happen? As I said that once we are shifting some people to a higher altitude. So, as I said that those who will be able to adapt with the new environment, so they will survive and other will be eliminated from the process. Then those member of the population with less adaptive trait will die out, and those member with more adaptive character will flourish, and this results in evolution of species. So, now what we are doing basically, so we are trying to implement this principle of nature artificially in finding the optimal solution of an optimization problem, mainly for nonlinear optimization problem. So, we try to apply the principle of your natural selection artificially for solving an optimization problem. Okay. Now, what is genetic algorithm? The genetic algorithms are the heuristic search and optimization technique that mimic the process of natural evolution. Okay, the process of natural evolution. So, this is basically, so what we are trying to do here, we are trying to mimic the process of natural evolution. So, genetic algorithms implement the optimization strategies by simulating evolution of species through natural selection. Okay. So, we are trying to apply the law what is basically what nature is following artificially, and then we are trying to solve the optimization problem. Now, history of genetic algorithm. So, evolutionary computing was introduced by I. Reisenberg in 1960s. So, around 60s this principle or around 60s people have discussed about evolutionary computing, but at that time it was not very popular. So, people did not accept that one as an optimization method. Okay. So, it was just discussed. Some people have tried to solve some simple optimization problem using this concept, but at that time it was not very popular. Even if today also some people are telling that genetic algorithm or other meta-heuristic optimization method, they are not really an optimization technique. So, they are telling that classical method are only the optimization method. So, genetic algorithm or other meta-heuristic optimization methods are not really an optimization technique, but the other groups are saying the problem which are not your treatable. So, which you cannot solve using classical method, that you can solve using genetic algorithm or other meta-heuristic optimization technique. So, now many people have accepted this algorithm, but in 1960s, so people did not accept that as an optimization technique, and in 1975, so Professor John Holland, so he was professor in the University of Michigan, and he wrote the first book on genetic algorithm, that is Adaptation in Natural and Artificial Systems. So, that is the first book on genetic algorithm written by Professor Holland, and at that time also this algorithm was not very popular. People did not accept it as an optimization technique, okay, for or optimization or powerful optimization techniques. People did not accept that genetic algorithm as a powerful optimization technique. Then David Goldberg, so he was a student of Professor Holland, so PhD student of Professor Holland, and he did lot of work on genetic algorithm, and he eventually wrote a book in 1989. The name of the book is Genetic Algorithm in Search Optimization and Machine Learning. Okay. So, it was I think one of the most popular book at that time, and then he tried to use genetic algorithm in solving different complex nonlinear optimization problem, and finally he could establish that genetic algorithm as a powerful optimization technique. Okay. So, and after Goldberg, many people have used genetic algorithm in solving complex optimization problem, and there was another type of genetic algorithm, we call it genetic programming. This is not an optimization method, but they use the principle of your natural evolution. So, in 1992 John Koja used genetic algorithm and to evolve program to perform certain tasks, and he called that method as genetic programming. Okay. So, this is how genetic algorithm has evolved, and after that many people have used genetic algorithm, and now I think it is one of the popular methods for solving nonlinear your non-convex your problem, optimization problem, nonlinear non-convex optimization problem. Now, let us discuss the simple genetic algorithm. Okay. So, first I will discuss this one, and then I have also given the pseudocode for implementing the simple genetic algorithm. So, here this algorithm anyway, so you are starting this algorithm and then generate initial population. So, what you are doing, you are generating a not a single solution, but a population. Population is nothing but set of solution. So, if you look at the basic difference of this algorithm, genetic algorithm with the classical method. So, most of the classical method, what we do basically, we start our algorithm from a single initial solution, but here the difference is we are not starting from a single solution, but we are starting from a set of solution, and we call it population. So, in nature we call it population, and therefore, we call it population, and now we are initiating the population, we call it initial population. Now, next is the evaluate the solution. So, evaluate the member of the population. So, suppose your population is 10 or the population size is 15, that means it is a set of 15 solutions. Now, you evaluate this solution. What is evaluation means? You are trying to put a number which will show whether that solution is a better solution or inferior solution. So, you are trying to quantify that one using a number, and we call it evaluate solution. So, I will discuss about how you can assign a fitness value to this particular solution, and we call it evaluate solution. And after evaluation, what you will do? You will check for termination criteria. That means this loop cannot go on and on and on, because you have to stop this loop, because in case of natural evolution, that loop is continuing now, this process is still continuing, but in our case I have to get a solution. So, I cannot continue suppose I cannot continue that one. So, I have to terminate this algorithm. So, therefore, some termination criteria you have to put here. Now, what should be the termination criteria? So, I will discuss in details in some of the classes, but termination criteria, one criteria may be the number of iteration, we call it generation. Okay. So, in this case, we call it generation, but it is nothing but the iteration. So, now this iteration can be a termination criteria, that I would like to iterate for 100 iteration. Okay. So, I would like to continue 100 iteration or 500 iteration or 50 iteration or something like that. That can be a termination criteria. Okay. Apart from iteration, there may be some other termination criteria, that you have a population of solution, and there is a base solution in that particular population, base solution. Okay. You have 50 solution, and out of 50, 1 is the base solution. Now, this base solution is not changing for some generation. Okay. Suppose it is not changing for 10 generation, or it is not changing for 50 generation, something like that. So, that I can put actually, that if it is not changing for some generation, that means you have reached the, or you got the optimal solution, and that is why you are not getting any improved solution for last 10 generation or 50 generation. So, in that case, what I can do? I can declare that I already got the optimal solution, and therefore, I would like to terminate this iteration. So, that may be another criteria to do that. So, I will discuss about this thing. So, we are putting some termination criteria. If it is satisfied, then you will stop and you will declare that you got the solution. But if it is not, the termination criteria is not satisfied, so in that case, what you will do basically? No, in that case, you will go through these 3 operators, okay, and we call it these 3 genetic operators, that is selection, crossover, and mutation. That whatever solution it will pass through these 3 operators, and then these 3 operator, what is the function of these 3 operator? So, these 3 operator will generate some new solution. Okay. So, I will discuss how this operator can generate new solutions. So, they will generate new solution, or we can say new generation they will generate, and once they are getting new generation. So, this is the, you are getting a new generation, and that is t equal to t plus 1 new generation, and then this termination criteria will satisfy, you will check, and then this iteration will continue. Okay. So, this iteration will continue till this is not satisfied, and once the termination criteria is satisfied, so you will get your solution. Okay. So, you will get your solution, optimal solution. Okay. So, this is the simple genetic algorithm. So, I can implement using some programming language. So, I can use any programming language, that also we will discuss. And now, this is the pseudocode. Okay. So, the function is SGA, simple genetic algorithm. So, this function is starting with initial population, and then you calculate the fitness function. Okay. So, you assign a fitness value, and that will basically show how fit that particular solution is. So, you calculate your fitness function, and then this loop will continue, while loop. So, while fitness value is basically not meeting the termination criteria, and then this solution will go through this selection operator, crossover operator, mutation, and you will calculate the fitness function again, and then this loop will continue. Okay. So, this is the pseudocode. So, it is, the algorithm is not very difficult, this is a very simple algorithm, concept is very simple, but it is one of the powerful algorithms for solving your nonlinear, non-convex problem. Okay. So, basically you are going through selection, crossover, and mutation operators. So, these 3 operators. So, we will discuss these 3 operators, but the basic idea is that you are creating some new solution from the earlier solution. So, from one generation to another next generation. So, you are creating some new solution. Now, let us discuss these operators. So, as I said, there are 3 operators here: selection, crossover, and mutation. Selection, crossover, and mutation. So, now we will discuss this genetic operator one by one, and I will also discuss what is the function of these 3 operators. So, what they do basically. So, that will be discussed, and how to implement that operator. So, that also will be discussed. The first operator is selection operator. Okay. The process that determine which solution are to be preserved and allowed to reproduce, and which one deserve to die out. So, what is the function? That this is a process. So, selection operator is a process that determines which solutions are to be preserved. Okay. So, which one you will preserve and allowed to reproduce, that means you will allow this solution to reproduce, and which one deserve to die out. So, basically we will try to implement the survival of fittest using this particular operator. The primary objective of the selection operator is to emphasize the good solutions and eliminate the bad solution in a population while keeping the population size constant. Okay. Suppose you have a population size of 10 solution. Okay. So, in a population or 100 solution in a population. So, what is this operator will do? This operator will try to create multiple copies of the better solution, and then it will try to eliminate the worse solution or inferior solution, and then it will also try to maintain the same population size. It will maintain the same population size. You have 100 solution, and after implementing this operator you should have 100 solutions. Okay. So, the basic idea is that the select the base, discard the rest. So, it will select the base solution, better solution, and it will discard the worse or inferior solution. Now, what is the function of this particular operator? So, the function of this particular operator, the function is identify the good solution in a population. So, this operator will identify the good solution in the population. Then the second function is make multiple copies of the good solution. So, this operator will create multiple copies, okay, of the good solution, and the third one is eliminate bad solution from the population. Okay. So, therefore, these are the three main function of this particular operator, selection operator. So, it will identify the good solution in a population, it will make multiple copies of the good solution, and it will eliminate bad solutions from the population. Now, how to identify the good solution? Okay. So, how to identify the good solution? So, we can identify the good solution using fitness function. So, using fitness function. Now, what is fitness function? A fitness value can be assigned to evaluate the solution. So, what I can do, each solution I can assign a fitness value. So, by looking at that value, you can tell whether the solution is a better solution, inferior solution, the best solution or something like that by looking at that value. A fitness function value quantifies the optimality of a solution. So, we are trying to quantify the solution. The value is used to rank a particular solution against all other solutions. So, using that value I can rank that particular solution against all other solutions. So, I can do that using fitness function. If a fitness value is assigned to each solution depending on how close it is actually to the optimal solution of the problem. Okay. So, optimal solution of the problem. So, I can do that using the fitness value. Okay. So, I have to assign a fitness value to the solution of that population. Now, let us take an example problem, and then I think the concept will be clear to you. I have chosen a simple problem here. This is the objective function minimize f, which is a function of d and h. So, d is basically the diameter of this can and h is the height of the can. So, what is the objective of this problem? Objective of this problem is we would like to find out the dimension of this can, which will basically minimize the cost. Okay. So, minimize the cost. Now, what is the cost here? Cost is cost of the material. So, material cost, that means surface area of this is pi d square by 2 plus pi d h. Okay. So, this is the surface area of this particular can and multiplying with C. So, C will convert it to cost basically, and this is the surface area you are getting, multiplied by C will convert to cost. Okay. So, I would like to minimize the cost, I would like to design this can or finding the optimal dimension of this can, and basically we would like to minimize this one. And there are some constraints. The constraint is that the volume should be greater than 300. Okay. So, volume should be greater than 300. D and H you have to choose in such a way that the volume is greater than 300, and there is a upper limit and lower limit of D, and there is a upper limit and lower limit of H. So, H and D should be between upper limit and lower limit. So, for example, if I have chosen, suppose if I say that diameter is 8 and 10 is the height of this can, and then I am getting 23 for C equal to 0.0654. So, for that this value of C, so I am getting the value equal to 23. So, this will give you the cost of this particular can. Now, question is that, so in this particular problem, so what we are doing here, we are trying to minimize the cost, and therefore, that if the objective function value is lesser, that means that is the better solution. Okay. So, in this case, the objective function value is lesser means that is the better solution. So, and it is more, suppose now it is 23. Now, if I have another solution, suppose another D and H, I am getting 24. So, then 23 is the better solution because cost is less. Now, if you have, so I can also just because I will just, the concept is something that this value is lesser means the solution is better. But if you have any difficulties in that concept, I can also convert to capital F, and in that case I can maximize this. So, capital F I can write 1 by 1 plus small f. Okay. So, I can do that. So, in that case, if capital F is more, that means the solution is better. If capital F is lesser, then solution is inferior. But I am not using it right now, but you can use this one also. Okay. I can convert a minimization problem to maximization problem using this, but what I am doing here, I am trying to see this value, and if that value, objective function value is lesser, that means that is a better solution, and if it is more, that means that is an inferior solution. So, what selection operator will do? And how we are implementing this selection operator. Okay. There are different techniques to implement selection in genetic algorithm. So, I have different algorithm for that, different techniques for that. So, some of them are tournament selection. One is roulette wheel selection, then proportionate selection and rank selection. Okay. So, we will discuss one by one. So, I can implement one of them basically, or there are some other your selection operator also, or you can have your own selection operator, but you just remember that what is the function of selection operator, that you have to identify the better solution. So, this is one function, and then you have to make multiple copies of the better individual, and then you have to eliminate the inferior solution. So, that is the function of selection operator. So, with this function you can apply, or you can have different technique, but objective is to eliminate the inferior solution, getting multiple copies of the better solution that you have to implement. Okay. So, I will discuss one by one. So, let us discuss the tournament selection. What is tournament selection? So, in tournament selection, several tournaments are played among few individuals. Okay. The individuals are chosen at random from the population. So, it is with randomly chosen. Okay. The winner of each tournament is selected for the next generation. The winner will go to the next generation. Okay. So, this is the tournament selection, and selection pressure can be adjusted by changing the tournament size. So, I can actually I can adjust the selection pressure. So, I will discuss this thing in details, what is selection pressure, and then weak individuals have a smaller chance to be selected if tournament size is large. Tournament size is large means there will be more selection pressure. Okay. So, tournament size is large in that case. So, I will explain when I discuss with an example problem. So, this is the tournament. So, idea is that, so you just select randomly from the population, you select few individuals, it may be it should be more than 2, the minimum 2 you have to select, and then you can select 3, 4, 5, something like that. But if you are increasing your number, selection pressure will increase. So, I will also discuss what will happen if selection pressure is increased. Okay. Suppose then what we will do basically, I am picking few individuals and ask them to play tournament. Okay. So, maybe it is a boxing tournament or something like that. So, what you are doing, this individual will play now. Okay. And at the end of the game, one will be winner. Okay. And this winner will go to the next generation. So, this is a very simple concept to implement selection operator. The winner one will go to the next generation. Then what I will do? I will have a different tournament. So, next time I will select another group and they will also go for the tournament and winner one will be selected. So, that way they will, all the member of this population will play a tournament and the winner of that tournament will go to the next generation. So, this is the idea of tournament selection. Now, let us take this example problem. Suppose I am just explaining like, so I have total 6 solution. Okay. So, this is first set, this is second set and this is third set. So, I have 6 solution. So, what I am doing here, this 6 solution, so I am putting in a box. So, just I am explaining the algorithm. So, what I am doing, I am putting in a box and from that box randomly I am picking 2 solution. So, when you are picking these 2 solution, the first trial, the 22 and 13 is coming. Okay, 22 and 13 is coming. So, now they will play tournament. Then the stronger one will win the tournament and they will go to he will go to the next generation. Now, in this case, what is happening? That this is 22 and this is 13, but though it is 13, this is actually violating the constraint. So, if you recall the problem, so what we have discussed, the problem is minimization of cost, but at the same time the volume of the can should be 300. Okay. Now, it is not 300, so it is somewhat 270 and therefore, there is a violation of 30. So, this is an infeasible solution and I do not want to select this solution and therefore, I am putting this violation here, though cost is 13, but solution is infeasible and that cannot be selected. So, I am putting the violation. So, now if they are playing tournament, 22 is the better solution and 22 will be selected. So, in the next trial 32 and 40 is coming and out of 32 is the better solution. So, 32 will win the tournament and in the third trial 7 is coming with 25, but 7 is an infeasible solution. The infeasibility, the violation value is 45 and therefore, 25 will be selected. Now, what I am doing here, so we have total 6 solution and out of 6, so how many if I select 2 individual for a tournament, that means my tournament size is 2. So, in that case what will happen? I can play 3 tournaments, is not it, because my total solution is 6. So, 3 tournaments means 3 winner. So, I am getting 3 winner and these 3 winner will go to the next generation. Now, what is the another purpose of selection operator? As I said that the size of population size should be constant. That means, so I have 6 solution and after the tournament I should get 6 solution again. But now, in the first set of tournaments, so what I am getting? I am getting 3 solutions. So, therefore, what we have to do? We have to play the tournament again. Okay. So, we will ask them to play the tournament again and this time also I am selecting randomly. So, now what is happening? 32 is playing with 25 and 25 is the winner, and then 40 is playing with 22. So, in that case 22 is the winner, and here both are infeasible, and 7 is playing with 13, and in this case this is basically little bit the violation is your less here, and therefore 13 will win the tournament. Now, from this tournament, so from the second tournament also, second round of tournament, I am getting another 3 solutions. So, in the first round I am getting 3 solutions, in the second round I am getting 3 solutions, and therefore I am getting total 6 solution. Okay. So, this 6 solution I am getting, this is 3 solution I am getting from the first round, and this 3 solution I am getting from the second round. Now, you look at this solution. Okay. So, 22 is the best solution in the population. So, 22, what is happening, because he is the best solution. So, whenever he is playing the tournament in the first round or in the second round, so he is the winner. So, 22 will have minimum 2 copies. Okay. Now, what is the worst solution? So, worst solution is 7, okay, 7 with a violation of 45, that is the worst solution. So, he will not be able to win the tournament in both the time. So, he will have 0 copies, is not it? So, the worst solution in the first round also he was not winner, in the second round also he cannot be a winner. So, therefore, he will not have any copies, that means the worst solution will not have any copies. So, you can see here, but the other solution depending upon who is playing with whom, so they may have 1 copies or 2 copies. Okay. So, therefore, finally, I can conclude this thing, the best solution will have 2 copies, the worst solution will have no copy. So, he will not have any copy, and the other solution will have 0, 1 or 2 copies. Okay. So, they will be between they may have 0 copies, they may have 1 copies, or they may have 2 copies. Okay. Now, if you look at what I am doing here, my tournament size is 2 in this case. Okay. And therefore, I am playing this tournament that 2 rounds. Okay. First round I am getting 3 solutions, and second round I am getting another 3 solutions, is not it? Now, if my tournament size is 3, then what will happen? So, that means I am taking 3 solutions and I am asking them, you go for tournament, and out of 3, 1 will be the winner. So, therefore, in the first round how many solutions you will get? You will get 2 solutions, because tournament size is 3 now. So, you in the first round the 3 is playing, first 3 is playing, and then second 3 is playing. So, you are getting 2 solutions. Then what you have to go? So, to get 6 solution, how many round you have to play? You have to play 3 round, because every round you are getting 2 winner, the second round you are getting 2, third round you are getting 2, and all together you are getting total 6 solution. Now, if you look at the best solution, the 22, what will happen? He will win the tournament in the first round itself, second round itself, third round itself. So, he will have 3 copies, is not it? So, he will have 3 copies. Worst solution anyway, so he will not be able to win the tournament. So, he will have 0 copies, and other may between 0 and 3 copies depending upon who is playing with whom basically. So, now this is called selection pressure. So, what is happening? If you are increasing your tournament size from 2 to 3, that means best solution will have 3 copies. Now, if you are selecting suppose tournament size of 4, then the best solution will have 4 copies, something like that. So, now basically, so if you are increasing your tournament size, then the best solution will have multiple copies. So, we do not want that. That is also not good for the search process. I will also discuss when I will discuss the other operators, then you will appreciate. So, we are not basically 2 or 3 is fine tournament size, but we are not using tournament size of 4, 5 something like that, because your population will be saturated with the base solution. So, that we do not want. Okay. So, and we will avoid that one. Okay, then let us stop here. So, we will continue our discussion on genetic operators tomorrow. Thank you.